Hi guys, welcome to this tutorial. Today I'm going to explain how the Dijkstra's algorithm works. So I'm not going through the math behind it because I wanted this tutorial to be very practical. So we're going to dive right into it. So the Dijkstra's algorithm is an algorithm that is used to find the shortest path in between two vertices. So in our case, I want to find the shortest path in between this vortex right here, and then this vortex right here on the right. And the numbers that are marked over here in between those vertices are called the distances, and they are a characteristic of the edge. So this Dijkstra's algorithm, we're going to mark the distance in between two nodes as we go through the graph. So we're gonna start from this node right here. So we consider that the distance in between this node and the other nodes are infinity. So we're gonna mark infinity everywhere, just for a start. And then the distance from this node to the same node is 0. And then now we're gonna start to go through the graph. So the distance between this node and this node right here is 6. So I'm going to mark 6. And then the distance from this node to this node is 2. So I'm going to erase that and then mark 2. And then I'm done with this node, so we're gonna place an X over here. And then we're gonna compare the value of this node and this node. So 2 is smaller than 6, so we're gonna start with 2. The distance between 2 and this node right here is 5. So because okay, my bad, it's 5. Yes, it's 5. And the sum of 2 and 5 is 7. So I'm going to mark the number 7 over here because 7 is less than infinity. And then we're gonna move to this node because between 6 and 7, 6 is smaller than 7. So the distance between 6 and 7 is 8. And because 6 plus 8 is 14, which is greater than 7, we're going to leave the node as it is. Okay, I forgot to mark it X. Then we're gonna mark this X as well. And then we're at this node right now, node 7. And then because the distance between this node and this node is 10, and then 10 plus 7 is 17, I'm going to erase infinity and change that to 17. And then the distance between 7 and this node is 15, and 15 plus 7 is 22. So change this to 22. I'm done with this. And then finally, 17 is lower than 22. So I'm going to cover this node now. So 17 plus 2 is going to be 19, which is less than infinity. So I'm going to change it to 19. And then 22 plus 6 is 28, but 28 is less than 19, so I'll leave the graph as it is. So mark X here, mark X here. So the final distance, 19, is the length of the shortest path between this node, this vertex, and this vertex over here. Okay, so here I have another example of application of Dijkstra's algorithm. So from the previous example, we can say that to go through the Dijkstra's algorithm, we first need to record the distance between vertices from one reference vertex, right? We have to have a reference point, and then we do that without going backwards. And then if a smaller distance is found, we need to change it. And then we're gonna compare the new nodes and then find the smallest value between them and consider this new node as a reference point and then repeat the first step. So we have another example over here. So we're going to start from this node, and then we need to end up this node right here. So we're going to find the shortest path in between those two nodes. So first of all, as we said in the first example, the distance between the first node to the other nodes is considered to be infinity. So we're gonna write infinity, and then the distance between this node and the same node is 0. And then we have distance between this node and this node, which is 2. So we're gonna, because 2 is smaller than infinity, we're gonna replace infinity by 2. And then from the same node, the distance between 0 and this is 8. So we're gonna replace infinity by 8. Then we're done with this node, marked with an X. And then we're gonna compare the values of these two nodes. So 2 is smaller than 8. So we're gonna start with 2 first. Because 2 plus 5 is 7 and 7 is smaller than 8, we're gonna change it, this to 7. And then 2 plus 6 is 8, so we got 8 is smaller than infinity. We're gonna change this to 8. And we're done with this node. Between those two nodes that are both connected to this, 7 is smaller. So we're gonna consider 7 now as a reference node. So 7 plus 3, so we don't need to do 7 plus 5 because they will be going backwards. So that's why there is an X here. So we don't have, we're not gonna be tempted to come back to this node. So we're going to look at the distance between this node and this node. So 7 plus 3 is 10, but 10 is greater than 8, so we don't need to change the value in this node. 7 plus 2 is 9, 9 is smaller than infinity. We're gonna change the value in here. It's gonna be 9, and then we're done with this. And then the smallest between 8 and 9 is 8, so we're gonna start here. 8 plus 1 is 9. And 9 is equal to 9, which is the value of 9 in this very node right here. So we don't need to change this value. And 8 plus 9 is 17. 17 smaller than infinity. We're gonna change it to 17. I'm gonna be done with this. And then finally, we have this node. So 9, we don't need to come back here because we're done with this. So we have 9 plus 3, which is 12. 12 is smaller than 17. So we kind of change this to 12. That's it. So the smallest path between this node and this node has a length of 12.